IB in a circuit like the one we saw is 25 microamps, and IC is 1 milliamp. What do you think IE will be? Let's calculate. Get your calculator out and tell me what IE will be if IB is 25 microamps and IC is 1 milliamp. How much? Yeah, let's do milliamps. Give me the answer in milliamps for IE. 1.025. So IE, IB plus IC, 25 microamps plus 1 milliamp, 1.025 milliamp. Okay. See how there is not much difference between IE and IC? Let's do the second one. IC is 1.8 milliamps. IE is 1.98 milliamps. How much is IE? 0.18. Okay. Let's do the third one. IB is 120 microamps. IE is 3 milliamps. How many milliamps is IC? 2.88?
Yep.
Everybody get 2.88? Okay, so 2.88 milliamps added with 120 microamps, and you get 3 milliamps. Okay. Good. So now, let's do the next thing. DC current gain in a transistor. What do we mean by the DC current gain in a transistor? With all transistors, when they are manufactured, when you make these transistors on those silicon wafers, okay, whether it is a transistor, individual transistor, or a microprocessor, or an IC circuit, what you have is for those transistors, you have what's called a current gain, and the current gain is the ratio of IB and IC. So it's saying that it's the ratio of IC divided by IB, which gives you the current gain. We said a little bit of base current will produce a large collector current. How large? It's given by the value of beta. So, the way to explain this is that actually, let's do, let me take you to the appendix. Let's go to the appendix. Let's go to appendix 2 in the back, page 14. Go to appendix 2 in the back. Third item down in appendix 2, page 14. What is the parameter called? DC current gain, and the symbol on the left side of it is HFE. HFE. HFE is current gain, which is equal to, write down where it says HFE or where it says DC current gain, write down this, IC over IB. Write down IC over IB. So that's the gain. And for an IC of 10 milliamps, if you look at the table, And for an IC of 10 milliamps, what kind of gain do we have between minimum and maximum? What's the minimum value? 100. Minimum is 100. Maximum is 300. So, when they manufacture these transistors, let's say that there is a production line, and on a Monday they're making these transistors, okay? And it's a very clean room environment. You've got white coats, you've got silicon wafers, and very few places in the world make these transistors because of the expensive nature of the facility. But you've got humidity, you've got temperature, you've got the amount of N-type material, P-type material. So when they put this together, on a Monday, you might have a gain of 125. On a Tuesday, you may have a gain of 150. On a Wednesday production, you may have a gain of 200. There is a variation in this gain from one day to the next, from one batch of transistors. Everything's the same part number, okay? But from one day to the next, it might have a different gain. And so look at what the swing of this gain is. Anything from 100 to 300 for this typical transistor that we have, which is in Appendix 1. Go to Appendix 1. It is an NPN transistor, and the part number is 2N3904. This is the one we're going to work with in the lab, 2N3904 NPN, and it has a gain anywhere from 100 to 300. Okay? So with one transistor in your circuit, it might have a gain of 125. Your friend sitting right beside you may have a gain of 150. Somebody else in the lab might have a gain of 200. So it is all over the lab, from one day to the next. So that's what gain is, okay? So let's go back to page 6, and let's do the calculation for under example 2.